Good afternoon, everyone, and welcome to the latest SCLF webinar. My name is Alex MacRae, and I'm a member of the SCLF Executive Committee and one of your organisers for today. I'm also joined by Stephen Collins, and together we'll be looking after today's event backstage. So if you have any technical queries, then please just send us a message in the questions box. Before we get started, I've just got some housekeeping and a couple of announcements for you. You will have joined on mute today and your camera is off, so you can just sit back and relax and enjoy today's session. And if you do need to step away, then don't worry, you'll be able to catch up on our YouTube channel later because we're recording this session. And I'll put a link for this in the chat so you can have a look there and subscribe to our YouTube channel. I'll also be posting some information about our virtual conference, which is coming up in September, as we still have applications to speak that are open. As well as opportunities to support the conference as well as a sponsor. So keep your eye on the chat for that as well. And the last of the housekeeping is just to ask you to please fill in the short feedback form, which will appear when you leave the webinar today. We'd be especially interested to hear if you would like more sessions of this type of format. So please do let us know. So getting on to today's session, and we have something a bit different for you today in that we're hosting our first panel session, which brings together practitioners and regulators to discuss some of the hot topics in ground gas risk assessment and mitigation. This panel session builds on the recent ground gas mini-series and other webinars on the subject, which some of our panelists today have participated in. So a very big thank you to them for doing a bit of a double dunter for us today. So the purpose of today's session is to have an open discussion about some of the issues that you have asked us to speak about, and your questions that you've put to the panel in advance, as well as to pick up on some of the themes that have come up during the mini-series. We already have a lot of questions pre-submitted for our panel, and so thank you to everyone who contributed. We'll try our very best to get through as many of them as we can. And if you have any comments or questions that you want to share with the panelists, then please just put them in the question box. And if we don't manage to answer them live, then we will try to get back to you either maybe through a follow-up Q&A or maybe perhaps a follow-up session. As you're not able to chat to each other on this platform, what we've also done today is set up a SCLF Discord channel. So if you've registered for that already, then you can head across there to chat with other attendees. And I'll put some more information about that in the chat as well, if you, in case you missed it in your email reminder. So without further ado, I'm delighted to introduce our panel for today and to welcome our chair, Alex Lee. I'll put his full bio in the chat in a wee minute, but Alex is a technical director at WSP with 25 years experience and is a regular and experienced expert witness delivering multiple court cases each year, including the recent Corbridge gassing case, and maintains a presence and direction to WSP's more complex projects. He's a SOBRA accredited risk assessor and is accredited under all 4 discipline headers and is a chartered scrutineer for SOBRA and the BGS. He's a regular contributor to the UK guidance, including contributing to the delivery of the new UK guidance for the assessment of mine gas risks, which is due to be published very shortly by Claire. And joining Alex today on the panel, we have Matt Askin, who's manager at GGS, Sarah Hamill, a contaminated land officer at Dunbartonshire Council, Esther MacRae, a contaminated land officer at the Highland Council, and Steve Wilson, Technical Director at Environmental Protection Group Limited. So I'd like to thank you all very much for joining us today, and I look forward to a very interesting discussion. So over to you, Alex.
Good afternoon, everybody. First of all, thank you very much for that, Alison. Wow, didn't expect you to read all that out, so that's, yeah, anyway. First of all, thank you very much for Alison to organising this, and just in case we do run out of time towards the end, I'd just basically like to thank SCLF basically for the opportunity today and for organising today's event, because this is a little bit unusual, and we do have today a incredible blend of panelists here, so this is a bit of a rare opportunity. And if I can say this, they might not thank me for this basically, but I think we have the influencers in the field on this one call, so that is fantastic. Looking forward to constructive debate, looking forward to hearing some, I suppose, some very informed decision. However, we do have an awful lot of questions that have been asked to us. We do only have an hour. We are going to try and keep it to the hour. I do have Stephen Collins is going to do a little dance for us, a TikTok dance to us, to tell us what time we're going to run out in 5 minutes, not towards the end. But fundamentally, if we do run over slightly, then hopefully it won't happen. But if we do, then do bear with us. The fact that we actually have so many questions is a reflection of the fact that so many people actually think this is an important subject. So that's great, but the downside is we're not going to get through all of them, I'm afraid. So please don't be offended if your question doesn't come up. We are going to try, and if a topic does go a little bit too long, we may close it down a little bit early, and we can maybe take it offline as well if required, because I do want to cover a few subjects. We also have a couple of polls running. We have, I think, 3 polls during the presentations today. Again, I don't want them to be a distraction. If we suddenly find that the polls are becoming a distraction or we are having IT problems, we may stop the polls, and we also may turn off the cameras just in case we do have IT issues. So yeah, let's take that forward. So basically what we're going to do today is we're going to try and cover maybe 3 areas: a little bit on field work, a little bit on risk assessment, a little bit on remediation. So I have tried to limit the questions a wee bit, but fundamentally what we'd like to do is start off straight away with a poll. So if Alison, you could bring up a poll straight off on question 1, which is to do with, and I'm going to call this out, I'm going to throw this out to the entire panel, so there's nowhere to hide on the first question, and we're going to start with a little bit of fieldworks, if you don't mind. So question number 1, should monitoring wells be vented, and if so, under what conditions, and what are the disadvantages and advantages of venting or not venting a well? So you should also see on your screen now, and I can see it, a quick poll, and the poll is open. So if I can also ask people to start filling that in and throw it to the panel to start answering the question, please. So does anybody in the panel want to start that, or put the hand up in the air straight off? I'm getting silence here. I can't see people anymore.
Well, shall I start it off?
There we go.
I think
yeah, you go there for Steve.
Well, mainly because I think the vented, people venting wells has probably come from some stuff that we started doing 5 or 6 years ago. And then it's suddenly, Steve says you should vent wells, right, we better do that all the time. So actually for the poll, there is actually, there should be vented, unvented, and it depends is what needs to be on there. Because we do leave venting wells or the gas taps open. We do it in certain circumstances to help us understand what's happening with the gas regime. Normally we leave them closed, but there, as I said, there are situations where we leave them open, and it has been quite illuminating. Interestingly, on one site in particular that I can remember, by leaving the taps open, what we demonstrated was that the flow rates were artificially high when the taps were sealed or closed. But interestingly, when we left them vented for a month, the gas concentrations actually increased in the well. So sometimes the vented wells give you the worst case conditions. But yeah, over to everybody else.
So what would the trigger be for you to consider them to be vented?
If we start getting high flow rates, which we think are not representative of the materials that are in the ground, that's usually what drives us towards opening them and leaving them vented for a while to see what happens. Or if they're flooded, or if the flow rates we're getting are just not representative of the materials that are in the ground.
And the continuous monitoring equipment vents?
It depends. You can set it up, but yeah, it will vent, because to measure the flow rates, it has to vent. So every sort of hour, you're releasing the pressure in the well. Yeah.
Yeah. So I think that's probably something that most people weren't aware of.
Yeah.
So in terms of continuous monitoring, it is being vented in the majority of times.
Yeah.
So the downside of not venting is of venting. What is the downside of venting? I.e., are we introducing oxygen to depth, for example?
I don't think you are, personally. The idea that you're going to get a load of oxygen flowing through a 3 mil diameter hole, or whatever it is, 6 mil diameter hole, it shouldn't make that. We've certainly not seen any adverse effects, that's for sure. I don't know what other people have seen.
So could it be argued that a natural system would be naturally vented anyway, and therefore by venting, you're reproducing or reconstructing the natural environment anyway?
You could, yeah. I mean, that's a very valid point, because outside in the soil around the well, particularly if it's flooded, for example, then you haven't got that sealed system in the surrounding soil. Yeah.
So arguably, so go on, Matt, after you.
I was just going to say, I think in the fullness of time, I mean, obviously monitoring is only a snapshot, whether periodic or continuous is only a snapshot in a longer picture. And over the fullness of time, venting will simply recreate what the natural system will be doing anyway over the full extent of your site. And you just remember that the monitoring well is just a tiny pinprick in the full spatial extent of the site. And I guess just returning to the substance of the question, and this will be something of a common theme, I think, in my responses, is that there's not necessarily an absolute right or wrong answer on the question of venting and not venting. I think the important thing is that you think about why you're choosing one or the other, you record that fact, and that you take those decisions and those factors into consideration when you're interpreting your results. And as Steve has said, there are different circumstances where venting or not venting can tell you something extra beyond the numbers themselves.
Okay, and Sarah, Esther, do you have any strong views on this? Have you seen these come across your desk? Esther?
I haven't seen this come across my desk, but in the first instance, I would expect the well to be unvented, so the tap's closed, and just review the conceptual site model, like Steve says, and if you're getting unusual readings that you're not expecting, then have a think about why that could be, and perhaps think about doing something different.
Yeah, I would add just pretty much what Esther was saying. We would, in most cases, I think they'll tend to be closed, but I think it's just sometimes maybe just going back rather than just taking that as given. And obviously, I'll come on to later. If there's looks at an anomaly, then look at other avenues and see if what that does. So I think, yeah, that would. But in most cases at the start, I think they're unvented. So which is the norm, I think. And then see what we're dealing with.
It's interesting because from a risk assessment perspective, when we're trying to assess, I'm going to use the word reasonableness and actual concentrations at the receptor, then obviously a vented well in principle is more representative of actual mixing and gas dispersion. So a vented well in principle, or arguably, is probably a more realistic basis for a risk assessment. But I think by doing a unvented well, get my terminology right, I'm going to tongue twist myself otherwise, an unvented well is giving you a bit of a, not necessarily a worst case, but a conservative pass first off. So I think where we're really getting to here is where we have high flows, we should consider it potentially, and where we have potential problems, we should maybe consider it as an alternative look. But the default position at the moment is we go unvented. What did the poll say? I can't see the results of the poll. I don't know if
the numbers I saw were 22% vented, 25% unvented, and a substantial 44% unsure.
That's what I expected. I think this is one of these areas, which is why the questions have risen, where people actually are unsure and what the criteria would be for deciding between one of the two. I think probably it's one of these subjects that in the future could probably do with a little bit of pen to paper and a little bit of clarity on it, under what scenarios and decisions you'd make it on. But that's really interesting. Okay, question 2, moving on, if you don't mind. A similar kind of question, if you don't mind. And there's also a poll for this one. We're going to on this one, and it's: do you believe any meaningful data can be acquired from wells that are flooded? Again, this one is, I noticed both Sarah, Steve and Matt have all put their hands up for this one as a potential subject they would like to talk about. So flooding of wells. Do you think it's possible to obtain meaningful data from flooded wells? Yes, no, not sure. This is a very emotive subject at times, this one. So please, anybody want to start on the panels while people are voting?
I'm happy to chip in some thinking on this. I think I think the answer is yes, but perhaps not necessarily in the way that the questioner means. I think you can get information on your well, you can get information on your site geology, and probably most importantly on your site groundwater regime. I guess far too often the interaction between groundwater and ground gas is, if not overlooked, neglected. And so I think definitely you can get value from flooded wells. It just might not be gas concentrations or flow rates, that is the meaningful data.
So are you inferring there that essentially the mere presence of a flooded well is telling you information on poached waters and laterally, groundwater flooding, etc.? It's telling you information upon permeability as opposed to gas migration, etc. And therefore, if permeability is low and or you have a shallow groundwater table, you're inferring therefore that the probability or the propensity for a gas risk may be lowered. Is that what we're inferring?
Yeah, potentially. I mean, obviously dependent on site specific and the CSM, but yeah, certainly, and showing consistency of flooding across a period of time or across seasons or years, that can be really telling on the credibility of your source or the credibility of your site as a migration pathway. So that's all meaningful and useful. But it's perhaps not what the original questioner was driving at, I would suspect.
Anybody else throwing it out?
Who else wanted to do it? I think
Well,
Sarah.
I was going to say as well, just we see this a lot, but the fact is sometimes it's just people don't even mention it. It's just we have to go back and go, the wells are flooded. And I think that's the problem. And I think it goes back to who's doing the risk assessment. People don't seem to see that as something that maybe needs to be looked at. And I think it goes, it's all about understanding what it is you're dealing with. I mean, I've got a site at the moment, there's one well that's flooded, that's with the gas concentration, the flow rate's the other side of the site, and it's PS2 going in across the site, and it's just not even been mentioned. And I think it's important that people understand there's a limitation and to, again, go back to assess. So that's what I would say as a regulator is everyone needs to look at it and address as to why, especially if it's an anomaly across a whole site, without just blanket gas measures can put in based on the first look at the data. So that's why I wanted to add it, because we see it all the time and it's not mentioned, and it takes us to have to go back to them. So
yeah, it's like every single answer is going to be think about it. But yeah, in terms of gas concentrations and flow rates, I would say that the majority of the time, the data from flooded wells is a waste of space. Because it is such an artificial sealed environment and it doesn't actually replicate what is in the surrounding ground. So even if you've got, I mean, the likelihood is that you've got dissolved methane in the water that's partitioning into the well headspace. But, dissolved methane at shallow depths is not a hazard to any buildings that are constructed above it, because it just sits in the water. There's no real pressure changes that can drive it out of the water. It just slowly sort of partitions. It will diffuse to the surface. But there's a capillary fringe above the groundwater table, which is really, really low permeability. Well, it's got a low porosity because it's virtually saturated to start off with. And that reduces the rate at which it will diffuse to the surface. And also for methane, it causes it to oxidize. And there's studies that we've got that demonstrate that. So I think, one of the things we see all the time is people quoting Abbystead and sort of suggesting that dissolved methane is a hazard to buildings. And that's complete rubbish, to be honest, because at Abbystead, you had water at 300 meters depth flowing from sort of 300 meters below the groundwater table to atmospheric pressure. Yeah, and that is like opening a very big pressurized Coke can. And you get shed loads of gas coming out of it. You do not get that at the surface, where you've got dissolved methane in groundwater at the surface. And we've got loads of data to show that, where we've monitored above the groundwater table in the unsaturated zone, which is where we should be putting. If we work, we do a lot of work in vapor intrusion world. And in vapor intrusion world, you do not put your vapor monitoring wells, your soil gas vapor monitoring wells, in the groundwater. You avoid it at all costs because we know it gives us misleading data. And yeah, in my view, the same applies in ground gas world as well.
Can I just add as well that we find, obviously, I think everybody, it's the gas, I think the bugbear is it's often seen as the last thing. So it's just like, oh, we're doing our groundwater, let's just monitor our gas. And I think that's the big problem, because it's just they're all monitored for the gas and groundwater wells. So I feel there needs to be a push for, you need to have your gas and your groundwater wells. So so they're looking in the right strata, but that's all the time. It's always the kind of the poor relation. The gas is just the last thing to look at, and it's no wonder they're flooded when you're going into your groundwater well. So.
And you probably find in all those reports it says we've done this investigation to BS 8576, blah blah blah. And if you read 8576, it says try and put them in the unsaturated zone and don't use groundwater monitoring wells for gas monitoring.
I think I agree with everything that's been said there. We are also in Scotland, so it's always flooded. It's always wet. But it does cause problems, and I do have empathy with consultants delivering, boreholes and so on and so forth. But there's two things that jump out at me there really. Is one, under the NQMS and LRCM and the National Planning Framework, there is an obligation for us to be considering and thinking about reporting uncertainty. And traditionally, consultants do not have a section on uncertainty in our reports. And obviously, what we're meant to be doing is, if we're following scientific principles, is data quality. And we and consultancies and industry as a whole still fail to challenge with the data quality. And obviously flooding is part of that data quality component. And then going off slightly on another tangent, when we looked at the SOBRA groundwater vapor gap, for example, there's some really interesting conversations in there about the effect of and the thickness of that capillary fringe, for example, by different geologies. And not to quote me on it, but the capillary fringe can be quite extensive depending on certain geologies. Rarely, if ever, do we discuss the capillary fringe within a permanent gas risk assessment as an industry. And yet, it obviously is a component within a vapor gas risk assessment. So there is one issue there that we do repeatedly, I suppose, disappear and don't consider. But I agree again with Steve about the fact that, Henry's law constant partitioning between, the dissolution of a gas into a headspace as a function of its partial pressure. So we have a bit of methane dissolved in a borehole, which is a sealed unit. It's basically going to go to equilibria. We then report it as a gassing issue because we get a short bit of flow, which actually brings me on to the next question, really, if you don't mind, and it's to do with flows, and basically the question is, it's just hopefully going to be a short question and a short answer here. How long, basically, do you think people should be standing beside boreholes trying to attain steady state flow?
That depends on the borehole.
Depends on the borehole, but okay. But if it depends on the borehole, we often see people waiting, saying that we reach steady state flow in 30 seconds or 1 minute or 2 minutes.
Yeah, that's uncommon.
Yeah.
I would say, or not really.
Okay, so how long? Just out of sheer curiosity, what's the expectation?
5 to 10 minutes will commonly get you where you need to be.
Okay.
We start off with a minimum of 10 minutes.
Minimum of 10 minutes.
Yeah.
And obviously the consequences of getting that wrong, if you are going to use your peak flows, means that your GSV is calculated and it's going to be wrong. So the consultant spent all this effort doing 6 visits, traveling 150 miles there and back to get to the site. And then because he wants to book off for his lunchtime, spends 1.5 minutes beside the borehole. And then following that, essentially all your GSV calculations are wrong. So a bright spot, and I suppose one of the easiest things consultants can do to improve the data quality is simply be a little bit more patient by the wellhead. Is that fair to say?
I mean, it is. And like I say, we start, when we specify gas monitoring, it is a minimum of 10 minutes. But again, it comes back to think about it. So if you're just recording 0.1 litres per hour, then there's no evidence of any flow, you're not going to sit there for 10 minutes. It's fine to stop it after a minute or so. But equally, when you sort of whack it on there and you see 80 litres per hour, and after 2 minutes it's dropped to 60 litres per hour, and then somebody in a set of result sheets is quoting that as a steady state value, you're pretty certain that it's not a steady state value,
Yeah.
and that if they'd have stayed there longer, you would have got a much lower value. And then if you do, again, if you start at 80, you get to 10 minutes and you see a gradual drop to say 30, you sit there for another 10 minutes. But
yeah,
unfortunately, that doesn't sit into the commercial model of a lot of site investigation companies.
yeah, I'm afraid not. But I think there's a reasonableness request here as well, and I think there's well, I believe, and we see this in peer reviews, and I'll be honest, we see this also internally. The tradition has been that wrongly, that this is something that's often overlooked. It's like flooding, and actually, the two most obvious things, well, two of the most obvious things, should I say, in terms of improving data quality, is understanding that issue of flooding, but also simply understanding that consideration of flow. And before we even consider doing any form of assessment, all consultants should be addressing those as part of their design and as part of their actual monitoring program. And I think that's fundamentally often missing before we even go any further to any more of the detail.
Yeah.
On a similar question, bringing into the third question here then is, we've been asked, one of the assumptions in the 2019 gas regimes paper, so this is directed really at Steve here, I'm afraid, Steve, is the response zone should be fully penetrating to an impermeable body, e.g. top of the clay. What are the consequences of not doing that?
We've not actually looked. We looked at all the sensitivity in terms of the response zone depth, but we never, to be honest, we've not looked at the difference between a partially penetrating and a fully penetrating well. My gut reaction is that it won't make a lot of difference in reality if you're using it sensibly and not just blindly following numbers. But you have to remember that when we sort of developed that method and the sites we were looking at, in actual fact, it's the groundwater for gas. So if you were looking at a fully penetrating well in groundwater analysis, you need to go to a clay strata effectively. But with gas, you only need to go to the groundwater because that is the impermeable flow boundary. So virtually all the sites we looked at when we were playing around with the numbers actually met that requirement. I'm sure they will be, particularly in Scotland where you've got sort of solid rock geology. You probably will have situations where it's not appropriate. But then, to answer one of the other questions, it doesn't apply to rock anyway. So yeah. Right.
We actually, just for the audience's benefit, we actually have quite an awful lot of questions on Steve's paper. If we have time, we're going to come back to those more detailed questions on your paper. But what we're going to do is we're going to keep it quite high level at first. Now I've got lots more questions on fieldwork, but I am going to move on to risk assessment because it's 1:30. So I'm going to throw a quick question directly to Esther and Sarah, really, which is a regulatory question, really, if you don't mind. And this has come from via one of the webinars that was being delivered. This is more of an opinion piece, really. And the question is, the application of a robust CSM has been part of our approach for a number of years now. However, we continue to have pushback from regulators and sites where we've discounted gas risk using the CSM. Is this the experience that others have had? So essentially, whoever's submitted that question is asking, really, can we just submit a CSM on a site?
Yes, you can.
Go for Esther.
Yes, you can, and we would accept that. And we have seen reports come in where ground gas monitoring is recommended for very, very thin layers of mid-ground, and we have suggested that perhaps that is not necessary to the consultant. So yeah, we would be happy with a conceptual site model because we do think that sometimes for low-risk sites, site investigation gas monitoring is undertaken unnecessarily and it doesn't find anything.
I'll just come in as well. We are more about, yes, we would, but we need to make sure we feel comfortable that actually the person doing it knows what they're doing and not just chucked it in. Quite often these decisions are made And to be honest, I don't think I've ever seen anybody not do gas monitoring, because it's done by the time we get the report. But if somebody came back with a good CSM and they could demonstrate quite clearly that they understood the site and the risks associated with it, then I don't see the harm. So I'd be interested to know who's saying, because I can't understand that I've not seen anybody discount gas monitoring. It seems to be done as a matter of course, and I say sometimes, for many reasons not maybe well thought out. So yes, but don't worry if we ask questions, because that's what we're here to do. So as long as you can answer them, that's when we would question it. So, yeah.
Can I defend the local authority? It is really, really refreshing to hear you say that, and I hope everybody who is on this meeting heard that, yeah, and takes note of it, because we pick people up quite a lot on doing unnecessary gas monitoring, and the normal response for the consultants is, the local authority will insist on it. And that is clearly not the case. And, you know, I've had conversations with other local authority people who you know, they've got the same opinion as you. If it's well presented and justified, they won't insist on gas monitoring.
Yep.
Yeah, I think quality is key, really. I can totally understand local authority officers insisting on things where the CSM is quite transparently poor, and obviously you would support them in that. But a detailed, robust, competently delivered CSM will very often convince, and if it's not, then it's kind of failing on its own terms.
I mean, we had this scenario as well, that it wasn't just gas, it was vapour, but the site clearly had 3 pockets of ash on the site, and there was a vapour membrane across all of them, and it was like, we actually said in front of the developer, would you not be better maybe removing the ash? No. And it was very clear where it was found was where the ash was, and there was just 3 pockets. So you know, it's just sometimes it's just the go-to kind of thing. So yeah, it's not for us to downgrade, but we can ask the questions and suggest either way kind of thing. So yeah.
I mean, I would suggest that a poor CSM, gas monitoring is not a substitute for a poor CSM. If you've got a poor CSM, you just should chuck the whole thing out.
Do a better one. Yeah.
Yeah.
Yeah. I think it's possibly also to do the way that procurement occurs sometimes, though, from a consultant hat. You know, a lot of the time the CSM hasn't been actually, defined at the time of actually writing the proposal and defining the scope, albeit obviously the objective of the CSM is to refine that scope, and there is obviously supposed to be an option to do that during the journey. But unfortunately, a lot of the time it doesn't. It gets carried over. But it is refreshing to hear that. So thank you very much to the local authorities on the call. That's good news. Okay, the next question basically is basically about the fact that Series 659 uses terms when we assess risk. We should be assessing the risk in terms of perceived, practical, and potential issues. So it's about being concrete and credible in one sense. And one of the issues that we often have is just, I suppose, really where we sit within the design cycle of a development. We're often not always there right towards the end of a development. The question really is, should be consultants caveating their reports and stating that the risk assessment is incomplete until final designs have been agreed? Should consultants be introducing the term reasonably foreseeable as a limitation also within their investigations? That's probably a local authority question to start with again. Sorry, Esther and Sarah.
Yeah, I'll come in there. This is something that we have, again, a bugbear with, because obviously remediation strategies are quite often written before detailed design stage. So it is a bit of like, it's not really the consultant's responsibility so it can be at the options. So you get, it could be this or this equivalent. So at that stage, and then obviously there was a bit, we were faced with questions when we started asking for detailed design, and we were getting told, well, that's not for you to ask that. So we now actually in our authority have introduced, much to everyone's despair, a kind of a new condition that requires, as well as and now it can be remediation strategy, but we call it remediation scheme. and that's where we get more detail about. It can be material management, it can be implementation plans, so it's much more that, because it might not be the consultant, it could be a separate, and some people see our conditions as one person's responsibility. So with this new condition, it allows us to get more information with the contractor or with anybody, so it could be in your strategy, but I think it's important that anybody knows that just because we sign off a remediation strategy, that's not the end of it. They still need to come to us, and that might be at building warrant stage, etc., etc. So we get round that to say, I think people need to know that that's not the end of our role as regulators. We will want to see the detail and know that what the measures are, the 3 layers of measures that are going in for gas. So that's how we get round it in West Dunbartonshire anyway. And it does seem to be working, because we have not all the time, but we seem to have more discussions with contractors as well. So they're taking cognizance of what was said in the consultant strategy. So that seems to be working anyway for the moment. But yeah, that's how we get round it. But definitely, there definitely is a caveat that that's not the end of it. I think quite often it might be, depending when the strategy is agreed. Yeah. But also our condition allows for you to, it allows you to also review your strategy. I think people forget that can be done as well through the process. So yeah, I don't know about other authorities, but that's how we work it anyway.
Yeah, we don't have a second condition, but we do expect, especially on design and build contracts. So the consultant's been brought in for the site investigation part of things, and they've come up with a generic remediation strategy. But for the gas protection, it very much depends on the design, and so that gets contracted out at a later date, and the contractor will then have their own designer who will have their own consultant. So there will be a different consultant brought on board for the more detailed remediation strategy. So it can be complicated, and so it's so long as in the initial report you address the fact that this is just, as I think the question said, that it is based on the information that you have at the moment, these are the things. However, these issues will need to be clarified, and you can update that later, and it will be picked up, as Sarah says, by building control as well.
Well, I think as Alex knows this, but in the Clare coal mining report, we've actually said that for mine gas risk assessments that it should have a statement in it that it's got to be reviewed once you've got a design fix for the whole development, including the foundations and everything, then the gas risk assessment's got to be revisited. But that should apply to everything. I think the thing that's coming out here. A lot of people think that gas protection design is adding up some points from BS 8485, and it isn't. Yeah, in BS 8485, it says that you have to justify why you are assigning those points to a membrane, to a floor slab. You've got to do calculations for ventilation. There's a whole heap of things that you need to do, and because there is that crossover between risk assessment and the building construction and building design, my view is that the gas protection design should firmly sit in the field of people who are doing contaminated land. It's not just specking up a membrane, and the people a lot of the people who are doing the designs haven't got the skills and understanding of ground gas risk and all the peripheral things that contaminated land professionals, all the sort of background knowledge that we have. They just haven't got that, and they're not qualified to do gas protection design.
I think from a consultant's perspective, if we were, I'm talking generically here, but if we were being honest about it, we are often within the wrong part of that design cycle, and essentially we can do a gas risk assessment, but fundamentally we then find out 2 or 3 years later the foundations have been completely different or the layouts are completely changed. And we've had no oversight of that, and it's just not captured by the developer, nor is it captured by the consultant. And then there's a potential for conflicting court cases and everything else about who was responsible and who was actually contractually liable or accountable for such things. it's very difficult for a consultant to capture that, just because of the nature and of the way that developments evolve and funding models evolve, and the fact that projects stall and teams change, etc. If I was being, this is a personal view, but institutional control from a local authorities like you've done, Sarah, as a second condition, albeit the developers wouldn't like, is probably the simplest way of capturing it, because fundamentally, my own view is that, and again, we don't often do this, but we should be doing a lot more of it. I do believe, like in the mine gas report, we should be saying, by the way, this is our gas risk assessment based on current conditions. Any changes to it, one, we're not liable, and two, it should be completely revisited to account for vibro stone columns or changing foundation, whatever it's going to be. But actually, it's very, very difficult to have that transparency as a consultant. It's likely to be better captured by the regulator, is my view, but that is obviously it's a personal view.
Yeah, and what we find as well is quite often we had a site and it was actually the warrant, everything had been agreed, and then there was amendment to warrant, and that was when they changed the foundation solution. And it was only thankfully because we've got hope, and at the moment we're very understaffed, but we're usually quite a good working relationship, and our building control officers said, do you have any issues? And I was like, well, we'll need to relook at the gas risk. And I wasn't saying there was an issue, but I just needed to make sure they at least considered it. But that's somewhere that it could get by. If that building control officer going to offer a change in warrant and just signed it off, then really who is going to see? So I just feel everybody's got a responsibility to kind of be upfront and understand sort of thing. So
I think, to draw out Alex's point, I think the legal and kind of commercial reality requires that we give this a nuanced reply a lot of the time. But I mean, it should kind of be beyond statement that risk assessment is about assessing the risk in the ground, and design takes place in response to that. They're not one and the same. So kind of thinking of them as a single package is kind of mistake number one a lot of the time.
I'm just going to mention about then, in order to satisfy the local authority, we'll need to see a proposal for the verification. So, and that is that, the verification proposals are key, and they can only be drawn up once the final design is known. So I think for any site which needs remedial action, that then nothing can go ahead until we've got a verification plan.
Yeah, but it is interesting. Just this week we were challenged by another consultant saying they'd never heard of a verification plan. What is a verification plan?
There you go.
They hadn't been, and a local authority had never asked them for a verification plan. I'm not going to name said consultancy, but fundamentally there is also, to rely purely on institutional control, if I can call you that without offending, but to rely purely on that does require coordination across departments, and some local authorities are better than others, and some local authorities are signing things off without checking it, and so on and so forth. So we do have this issue wider about suitably qualified persons, about what is being signed off and not being signed off. But I think it was you, Sarah, who said the word, it's a responsibility for us all, and I think we all need to be getting better at doing it, consultants, clients, engineers, and the local authority. But I think one backstop is to put that content in. I know it might be necessarily favourable to others, but it is something quite logical to me. I've got another question on a very similar. It's actually a very similar theme, actually, and we're going to move on to this because I know time is passing. Well, let's do a yes/no answer to this one, really, just to keep time going. Somebody's asked, should gas wells be installed following groundworks and foundations? Yes, no, around the houses. I think your answer is going to be maybe. But it would be interesting to see what people
depends on your conceptual model.
Yeah, I thought that was going to be your answer. So, okay, well, I'll tell you, we're going to move on from that one then, because I am aware of the time, and I'm looking at Sarah's clock in the background telling me it's 1:45. Let's get your clock right there. Okay, so if it all goes terribly wrong, we're blaming Sarah for not getting a clock sorted. Okay. A further risk assessment question. When we look at risk assessment for human health under Part 2A, etc., we're looking at, I suppose we use the word reasonable a lot of the time, and it's about the arithmetic mean, and we have stats guidance, etc., about that. We're often not necessarily looking and being overly conservative, and remind people about the precautionary principle about avoiding hypothetical consequences and inventing hypothetical consequences, etc. So the quick question really has come in here, which ties into that, and is, should we actually be looking at the true mean of the gas concentrations for, say, over 6 monitoring rounds when we are determining risk? What are people's views on that?
I think that's the wrong poll, isn't it? That's not the question on the screen is not the one you just asked.
No. But you can, yeah, no. So we're talking about basically, it was very, very proactive bringing the poll up there. The question basically is that instead of using these worst case concentrations, and remember that British standards also contains that, I'm going to use the word get out, I can't remember the title, but the question is about worst case. There's a challenge on reasonableness within the British standard. But just what are people's views on, you know, human health? We use the arithmetic mean, but in gas risk assessment, we often find ourselves, or as an industry, using the worst case concentrations. What are people's views on that?
I think if the arithmetic mean is robust and representative, there may be merit in that, but that is a very, very big if, and I think it's probably seldom that six data points will give you that.
But I'm assuming if we had continuous time series from, say, a 2 or 3 month period, for example, from a gas clam or equivalent an ambisense unit, etc., then our data set would be sufficiently robust enough in order to calculate, say, a 95th UCL with confidence. So let's hypothetically assume that was the case. How comfortable were people about using the 95th UCL?
It depends. Well, it always is.
Yeah.
Well, the first thing is, what confidence have you got in the ground conditions and variation in ground conditions? But also, we have used 95 UCL. I don't think we've ever used mean values. But what it boils down to for us is, for a residential development, you've got very small individual units that could quite easily sit over a hotspot of gas. So you really need to think about that, because then it's like you use the maximum one because you don't know what's going to be sat on top of it. If we've got a big warehouse that's just big open space, then that's when we would start, you know, to start looking at, can we use 95 UCL?
Yeah. There obviously is there's issues associated with acute risks, but fundamentally as well, if you did do statistics on your data set, then you're going to do outlier tests as well, or you could consider outlier tests anyway. So if you, for example, had hotspots within that data, you'd be removing them from your distribution for your UCL anyway. So I think there is probably an opportunity to use them, but as you say, Steve, it has to be done within an understanding of your CSM and also a reasonable understanding of statistics.
I was just about to say that. Yeah, I try and avoid statistics at all costs, because you can get questioned on it very easily, and and drop a clanger.
And I think that there is I'm struggling to kind of put words to it, but there is have a slight discomfort about, particularly around arithmetic mean, applying that to something which is inherently variable. Pressure, temperature, volume, concentration, all of these things are changing all the time. One number, I think the threshold for robustness needs to be quite high to get anywhere close to that being a comfortable position for me, at least.
Yeah, and your data set would have to be pretty big.
Yeah.
So Esther, you had a hand in the Esther.
Yeah, I was just going to say the gas monitoring should really just be backing up what you think the site should be in your conceptual site model, and the characteristic situations, if you're using that as a way to classify the sites, are quite broad in their range. So if your site looks like it should be in conceptual site or characteristic situation 1, but you're getting 1 or 2 results which might push it up, then I think it's fair enough to say it's, broadly speaking, characteristic situation 1. So I think you need to look at your conceptual site model in detail and what you're expecting. And why is it you're wanting to use the mean or the upper 95th percentile rather than go for the max? Is it to drop it down a level in that? You know, there's a reason why you might want to do that. Yeah. So you have to be comfortable with the consequences of that as a consultant, that you are sure. Absolutely. Avoid risking it away, basically. Okay.
I don't like that term. You cannot risk something away. If the risk is there, it is there. What you can do is a correct risk assessment.
Okay. Mitigation. We're going to move on to mitigation. So we've got a question here on geocomposites, and basically we're going to have a question. Interested to hear the panel's view on the use of geocomposite strips in ground protection measures design, both as pressure relief pathway or as design venting layer, specifically in relation to design limitations of their usage under each scenario. So not a short question. So again, can I open that to Sarah? Yeah, please.
Yes, I'll come in this one. This has been an issue that has been a bugbear of mine kind of for a year, really, lockdown, I would say. It kind of arose to us when we got a verification report and we're expecting a blanket and we got strips. So I just asked the question, oh, why is there strips? And then they explained, oh, you know, the reasons and the calculations. And then it's when I noticed the strips were connected at either end. So they weren't interleaved, which is what the guidance says. If you're putting strips in, there should be interleaved between the latent strips and the gravel layer. And then we were getting back and forward discussions as to why the calculations and the design only needed to consider the strips. So therefore the gravel layer in the middle didn't really come into the question. And we just went back and forth a lot over what the guidance said should be interleaved, and we weren't really getting any answers as to why they were right. It was more about what was wrong with the guidance. But as a regulator, we kind of need to focus. We can't kind of take a whim on things like that. So it kind of was back and forward for a while. So we ended up sort of getting sort of third party validated, because these buildings were up. So it wasn't even at the design stage, because it wasn't clear at the design stage how the strips, you know, well, in fact, it was a blanket to start with. So obviously the buildings are up, we're verifying, we're talking quite a number of buildings. So we said, well, we can't make this decision based on what you're telling us. The guidance is still the case. So it was third party validated. I think what we'd hoped, there was two developments had the same design. I think we'd hoped was across the two developments, it would show that this was appropriate method, but actually what we got was site specific, was okay for this site given a number of factors, the distance between the strips. So it still didn't really answer our questions. For these sites, it wasn't pressure relief pathway, it was a pressure relief pathway, it was the venting layer. So it was actually what they were trying to get, it was the main part of the gas measures. So on these sites in particular, with the third party validation and with further monitoring, we could accept it, but we still are left unknown. So what we've done, we've decided now, until guidance tells us otherwise or evidence is out there to support it, we're kind of okay with the strips going in for pressure relief only. If they're interleaved, this is non-interleaved sort of thing. This is, I don't know, it's quite specific design. So it's more to do with the strips and the interleaving between them. And it's just that what we're coming across, and I know some other authorities in the Central Belt have faced the same thing, and we have been told that we just don't understand it. And it's like, well, this is based on what the guidance tells us. We can't just go off on a whim. So that's our opinion anyway. For pressure relief, fine, because it is literally just the kind of final bit of the bit, you know, you've got your enough protection elsewhere. But when you want to start making your venting layer your main thing, then you maybe need to think about it. But interesting to hear other views.
Anybody else want to discuss this one?
Well, I would say that Sarah does understand it, despite claims that she doesn't. So if we look at pressure relief, so starting off with pressure relief, yeah, that is not, all that is doing is stopping the gas getting pressurized underneath the building. It does not have to dilute the gas. So you can have 100% methane under a building in theory if you've got a pressure relief layer. And geocomposites could run in straight through by and large will do that. To be honest, we've done pressure relief just using the sub base underneath a building on if the building's narrow enough. But you've got to justify that by calculations. You've got to show that the rate that the gas is coming up into the sub base, that it can actually diffuse sideways quickly enough so that you're not going to get a pressure building up. Now, to be honest, if the CSM is telling you that the gas flow is by diffusion, you're not going to get pressure building up underneath a building anyway. You know, this idea that gas diffuses up underneath a building, then suddenly builds up to this super pressure underneath the building. It just doesn't happen like that. So that's the first thing. If you are putting geocomposite strips underneath a building in gravel, then the guidance is quite clear, as Sarah says, that you have to interleave it. And the reason for that is that if you just put them from inlet to outlet, you just get airflow preferentially flowing through the geocomposite, and you won't get airflow particularly through the gravel at either side of it. And the reason for requiring it to be interleaved is so that it drags the air through the gravel to some extent. Now, I know that people have tried to measure the flow rate through interleaved strips and said, oh, we can't measure any flow. And that's because it's not a very efficient method, which is why you can't use it on particular big buildings, even on housing, to be honest. You know, you might be pushed. And I also suspect that in the sites where they've done it, that the gravel might not have been the right grading either. It might have had too low a permeability in it, because we quite often see strips put into type 1 subbase, and that just isn't going to work. Now you can, on houses, if it's not very big, if you have the strips running through from side to side and you've got preferential airflow, you might get enough diffusion. And if they're only at 3 metre centres, for example, you might get enough diffusion in and out of the gravel of oxygen or fresh air that it does actually dilute the gas in the gravel. But again, it's down to the designer to show that. But if you know, because I'm old and grey and I've been around a long time, I actually know where all this interleaving came from, and it came off the back of the Partners in Technology report, and it also came off the back of some designs we were doing at the time at Card Geotechnics, where Arups were the approving engineers. And we sat down with Arups, with Nico Riordan, I think it was, and Richard Owen back in the late 90s. And they were questioning because we'd put the strips through. And so we had long discussions with them about design calculations and how to get the airflow through the gravel, and came up with the interleaving, and then it's subsequently in BRE 414 in BS 8485 Partners in Technology. So it is based on some stuff we did years ago. Yeah, there's not been any research into it since then. So certainly, yeah, I'm not saying absolutely we're right, it should be interleaved, but if you're going to prove it, do it properly, is my response to that.
Yeah, I think that the final brief word from me on that is just to verify the quality of installation is a key factor.
Okay.
They have their place, but they need to work.
Thank you, Matt. Looking at Sarah's clock, we're nearly there. Okay. So if Sarah's clock's a bit fast, we're even faster ahead. Okay. We've got one final question. We have lots of questions, but actually we're gonna close out on this question. It's the last question of the day. There is a poll on this one as well, and it's probably one of the most controversial of questions. So if people do have to drop off the call, then obviously do as you require. But hopefully, you know, this will be an interesting question for the next 5 or 10 minutes as well. So my question is, should local authorities adopt a simple mandatory approach to gas risk mitigation measures in areas defined by the coal authority as former coal fields, including low risk areas, and require all new residential developments to install gas protection to a minimum of CS2? If not, why not? So there's a poll, I think. I can't quite see it on my screen yet, but I think there is a poll on this one. But when we do that, does anybody want to start off with this one? It's quite. Anybody who wants to kick off on it?
For my 2 pence, I think I'd want another option, which is absolutely not. I think it goes against kind of the foundation of contaminated land as a risk-based discipline, and just based on observations of kind of quality of protection measures installation as it currently stands, and the proportion of sites that actually pass through on the forced inspection. I think expanding the range of installation or the scale of installation to orders of magnitude more developments can only lead to poorer and less effective protection overall. It might give us a better sense of comfort, but I don't think it will give us any extra protection necessarily.
No, and I would agree with that 100%, because yeah, it should be risk-based. It's going to cause untold problems. It's a excessive cost to developers. You know, it's not just like, you know, £5 a square metre for a membrane. It's all the verification and it's all the aggravation when it goes wrong. And to be honest, I think that anybody who thinks that gas membranes go in completely intact in this country does not live in the same world that I live in when I go on construction sites. You see lots of pictures on LinkedIn all over the place of beautiful, pristine membranes after the installers have just put them in. When the house is built, they are not in that condition. They will be sawn through where they're putting the timber frames in. They will be nailed through. They will be ripped where the scaffolding's done it. And that, and in probably at least 50% of cases, I would suspect, is not picked up because it happens after the verification. And it's only by luck, if a verifier goes back on site, that somebody notices it, that it's picked up. So it is absolutely the wrong thing to do.
Local authority view?
Yeah, well, I'm kind of glad to hear that's the viewpoint, because I wholeheartedly disagree as well that it should be done. I think it's too easy just to think, just put standard measures in. You know, it goes against all the things of risk assessment, but you know, and it might not be enough. But there's issues with installation, as Steve was saying, but also we look at, from a regulator's point of view, it's the future ongoing responsibility. This is people moving into these houses. Now, somebody in the future might want to build an extension. Now, if somebody was to build an extension and ignore a condition that requires gas measures, as a local authority, if we kind of felt it wasn't needed, then how could we insist that they were to do anything? So I think it absolutely not, it cannot be done, and it needs to be risk-based. And I'm glad to hear that that's the view from others as well. I'm interested to see the poll when Alison's holding on to it till the end. Let us leave. I'm hoping it's categorically.
Well, can I just add something else? It can lead to a false sense of security as well. Because people will just be, oh, we don't need to do a risk assessment, we'll whack a membrane in. But there are instances where you might not want residential developments on a site because the gas risk is too high.
Yeah. I think it's an interesting one, because it's quite an emotive subject and one that's become quite lively, and we are increasingly seeing it through the peer review processes, etc. But I think really fundamentally, you know, the National Planning Policy Framework is about intended for use, as is Part 2A, as is planning, and it's about that suitable for intended use and a risk-based approach. So to take gas out of that framework will be in contradiction to the entirety of the rest of our UK, I suppose, spirit and principles of how we deal with land contamination. And before you know it, you could start setting precedents where we get made ground in asbestos, everybody starts doing, you know, defaulting, etc. So I think it's probably quite a dangerous precedent, personally. But I do understand that, you know, on small developments, I can see a little bit of logic from a developer who's thinking, well, save time in his program after this default up to CS2. But they're not necessarily really seeing it from the perspective of actually maybe CS3 or CS4 on site, etc. Or even maybe CS1, and they could have saved themselves some money. But yes, where is the poll? And have we got the results of the poll on the screen? I can't.
It did appear.
See them. It did appear, but it didn't appear on my screen, I'm afraid.
It's 55% no, 17% yes, and 29% not sure.
29% not sure. Okay, well that is quite interesting. The fact that so many people are not sure about it. That's quite an interesting observation in its own right. It would have, I suppose, really, as a balanced panel, it would have been interesting to have somebody actually on the panel who said, yes, it was, and yes, we should be doing them. But it sounds like an agreement. It's not necessarily a massive deep discussion about this, but I do think that what we are seeing here is we're seeing the opinion of, I'm going to use the word influencers again, and regulators, and I think both parties here are drawing the same conclusion, that this will be potentially onerous and therefore potentially unsustainable to deliver, and also could be misrepresentative in respect of actual risk to do so. You know, I can't personally see a defined logic for doing it when we actually start thinking about it a little bit deeper. If Esther, have you got Matt? Have you got any views? Go on, Esther, waving your hand.
Well, I just thought there needs to be further evidence and research into new builds, which are have different ventilation systems to previous houses and to gas migration within those new builds. They're much more hermetically sealed. So I can see why some people think, oh, we're just a gas membrane would just solve that issue. But I think it would be a false sense of security, as you say, but I would like to see more research. I didn't answer the question because we don't really have any coal fields in Highland, so I didn't think it would be fair to answer.
I think,
but I think I agree. It would be overly onerous in terms of cost, and also if you're just thinking, oh, it'll just be a more expensive damp-proof membrane, that's fine, I can cope with that. It's not, it's the verification, as Sarah says, and the ongoing maintenance and requiring of that site to then, every time there's a planning application for anything going on it, we have to make sure that that's not going to compromise it.
I think the other thing to mention about that, just quickly, is that Tom Henman at RSK did some work for Scottish Government, and that question was asked. So that there's quite a detailed response in the Scottish Government study on GoBridge, because he did some, he went around the industry interviewing people. So there is more. I think the conclusion there was pretty similar as well.
Yeah. We are getting towards the end of our time. We have gone a little bit over. Sarah's clock looks like it's saying nearly 10 past. I think we're going to call it a day. I would just like to conclude. Well, first of all, I'd like to thank the panel. It's for giving up their time. It is, you know, it's quite a commitment to do these things, because you never know what's going to be asked of you. We're being pretty polite, and everybody's, you know, contributed well, so that's most appreciated. I'd like to thank again all those members. It looked like we had a good 130 odd people on the call, which was fantastic. And I just really want to sort of a quick closing comment. I think summing what we have up today is that we have an awful lot of guidance and advisory documents out there. There's a wealth of documents out there on gas risk, etc. The requirement for more gas documents. Do we need more guidance documents? Possibly not. But fundamentally, we have an awful lot of guidance out there. Our weakness at the moment probably is simply that we aren't necessarily following them as an industry. And also my sort of observation, and I'll say this on behalf of WSP, and you know, we're a big consultancy. We make mistakes. Consultancies make mistakes. We're in a mature market, being driven by volume at times. But we do need to stand back and stop and reflect upon data quality and a bit more critical thinking, because otherwise we're going to get Sarah and Esther rattling the cages at us, telling us we deliver the rubbish, which I'm afraid to say is inevitable for all consultants at some point, when none of us are perfect, but we just need to get better at it. So thank you very much, particularly to the regulators, Steve and Matt as well, and we hope you've enjoyed it. And I understand that if there are other questions, we will try and address them. I've got 6 pages of other questions here, but I don't think that it's a whole confidence in its own right, some of the questions I've got here, so I think we'll call it a day there. So I think at that point in time, we'd like to close today's event. Hope you all have a wonderful afternoon, and again, thank you very much to all the panelists. So brilliant, thank you.
And thank you for chairing it. Thank you.
Thanks, Alex.
Yep, cheers, Alex.
Bye.
Yeah, thank you.
Care.
Bye.
Thank you very much. Bye-bye. Bye-bye.
Thanks a lot. I'd also
Bye.